Hey, hi everyone. In this video, we are going to solve the LeetCode problem of the day, and the problem is largest divisible subset. Now, this is a medium level of problem, and to solve this, we are first going to understand what is this problem all about. Then we are going to understand the approach, and we will also discuss the thought process behind that approach, and then we are going to code it using Python. So let me take you to my drawing pad and explain you the problem first. So in this particular problem, we are given an input, and the input is an array of numbers. We need to find out a subset out of this input such that in that subset, if you take any pair of elements or any pair of numbers, then one of the number will be divisible by the other number. So what I'm trying to say is, if this is your output, then you can take any pair. So let us take 2 and 4. So if your numbers are 2 and 4, in this case, one of the number out of this is going to divide the other number. So here you can see 2 can divide 4, right? How can you find it? 4 mod 2 will be equal to 0. So let us take the example of this 2, 8, 4. So we saw for 4 and 2, we can take another pair 2 and 8, and we can see that 8 mod 2 is equal to 0. And there is another pair which is 8 and 4, and for this we can say 8 mod 4 is equal to 0. So for all the pairs in our output, the condition is true that one of the number is able to divide the other number. And you will have to keep one more thing in your mind, that the output has to have the maximum length which is possible for this given input. So for this given input, we can create another subset which is 9 comma 3, right? This is the first element, this is the second element, and this has just one pair which is 9 and 3, and the condition is true that 9 mod 3 is equal to 0. But the length of 9 comma 3 is 2, and the length of 2 comma 8 comma 4 is 3. We need to output that subset which has the most number of elements. So that is another condition, and that's why this answer is not correct and this one is correct. Now another property of a subset is we don't need to worry about the order of the element. So if the output is 284, it is correct. But you can also say that the output is 248, right? This is also correct because the elements are same. It's just that their orders are not same. So once we know this fact that we don't need to worry about the order, then the first thought process to solve this is we need to sort our input. And the reason of sorting it is, see, if your output is 2, 8 and 4, then you will have to check for each pair 2 and 8, 8 and 4 and 2 and 4, that is the condition true that one of the number is able to divide the other number. But instead of this, if you will sort it and make it 2, 4 and 8, then you will not have to check for each of the pair. Instead of that, you can check only for the adjacent pairs. For example, 2 and 4 and 4 and 8. And the reason for this is, if 2 and 4 is valid, that is 4 mod 2 is equal to 0, and 4 and 8 is valid, that is 8 mod 4 is equal to 0, then we obviously know that this will also divide 8, right? Because if 4 is divisible by 2 and 8 is divisible by 4, then we will know that 8 is also divisible by 2. So if the input is sorted, it will be easy to check the condition that one of the number is divisible by the other number, and we will need to check for the larger number. The larger number will be divisible by the smaller number. So if it is not sorted and you get the pair as 2 and 8, then in this case we first need to check which is the larger number, because obviously 8 cannot divide 2, but 2 can divide 8, right? So in that case, first we find the larger number which is 8, then we divide it by 2 and check if the remainder is 0 or not. So instead of that, we can just sort our input, and we can say our input is not 9, 2, 3, 8, 4, but it is 2, 3, 4, 8 and 9. Now how to solve this particular problem? See, we need to find all the subset of our given input. So one of the process to solve this can be, you start with the first number which is 2, then you check for each of the subset which is possible and check which subset is having the largest length and satisfy the condition that all of the pairs are valid. So you can start with 2 and then you can check for the next element which is 3. So can you make a bond with 2 and 3? No, because 3 mod 2 is not equal to 0, it is equal to 1, right? So in this case, our current number 2 cannot bond with 3. So what will happen? We are going to check for 2 with other numbers, and we are going to check for 3 as well with other numbers. Now then we check for 4. So can 4 bond with 2? Yes, 4 can bond with 2, right? So you can say 2 comma 4. It can bond because 4 mod 2 is equal to 0. But can 4 bond with 3? So we are not sure that 4 can bond with 3, right? So 3 will continue, and also we will have 4 as an individual element as well. And then you will have to continue. You will have to check for 8. Can 8 bond with 2 and 4? 4 and 3. So it can bond with this. It can bond with 4 as well. It cannot bond with 3. So the next pair is going to be 2 comma 4 comma 8, 4 comma 8, 8 alone and 3 alone. And then you will check for 9. 9 will not bond with this one. It cannot bond with this. It cannot bond with 8 as well, but it can bond with 3. So our output is going to be 2, 4, 8, 4 comma 8, 8 and 3 comma 9 and 9 alone. So you got 5 subsets which are possible for this particular given input. Possible means all these 5 subsets are valid. That is, all the pairs which is possible in your subsets are having the condition that one of the element divides the other element. Now you can also include 2, 3 and 4 alone as well, because they are also possible. And the reason is, if you have a single element which is only 2 and you do not have any pair, so still this is a valid answer, that 2 is a valid answer. So an individual element is also a valid subset. Now this is fine. This is a good solution for this problem. But the problem with this solution is the time complexity of this is 2 is to power n. N is the number of element in your array, because we are generating all the possible subsets, and out of all the possible subsets, then you will have to check for each subset which has the maximum length, right? So this one has the maximum length, but let us say there is another element which is 27. So 27 will be part of this 3, 9, 27 as well, right? So in this case, 3, 9, 27 and 2, 4, 8 both are valid answers, and you can return any one of it. And it is mentioned in the question that if there are two subsets with same length, then you can return any one of it. But coming back to the problem in this approach, the time complexity is too high. We are going to follow an approach which has a smarter dynamic programming implementation. So let me explain. And I am going to explain you this approach using this particular input, and the output for this is this particular subset out of our array. So what's the approach to solve this? In this smarter DP approach, what we are going to do is we are going to assign two arrays, and the length of both the array will be same, and it will be equal to the length of our given input. So the given input length is around 10. Okay. So you will see that DP and previous both have the length of 10. Okay. DP will initially have 1 as all the elements, and this previous will initially have all the elements as -1. Now I will tell you the approach as well as the thought process behind this approach as well. Okay. Once you have this DP and previous initialized, I have taken the input as sorted, which I have already explained you that why we need the input as sorted. Now the thought process behind this particular approach is, instead of trying to get all the subset, let us try to find out the answer or the best subset which you can create at each index. Okay. So if we try to find out the answer at each index, then what we are doing is we are trying to create a sub problem out of our problem. So this is our complete problem, and each subset is going to be a sub problem, and we are going to utilize the result of it, utilize the result of the previous sub problem, and then we are going to combine it, and that is how we are going to use the smarter DP approach here. See, so when we are at index number 0, okay, so the element is 5, right? So this is our input. I have listed it in the nums column. So this is our input, this is the index, this is the DP, and this is previous. Now the DP value is changed. Initially it will be 1 for all the DP value and -1 for all the previous values. Okay. So when we are at index number 0, we just have one element 5. Now if I will ask you what is the output when the input is just 5, then you can simply say that the output is 5, right? This is one of the subset of our given input, and this is the best we can say, because it satisfies the condition that all the pairs are valid. Valid means one of the element is able to divide the other element. So if we take an array which is just 5 or just 9 or just 18, that is if it is an individual element, then the best length, the highest length which you can create as a subset which is valid is going to be 1. And that is why initially the value of DP for all the element in our array is 1. Now I will come to this previous as well, that why are we taking it as -1. Now when we are at index number 0, we got the length of our DP as 1 and previous is -1. I will come to this, okay, why it is -1. Now let's talk about when our array is not 5 but it is 5, 9, right? So if it is 5, 9 and we are at index number 1, right? So this is our array as of now, 5 and 9. So when you are at 9, we have already checked about 5. When we are at 9, we are going to ask the previous elements that what is the best you can provide for 9. So the only previous element is 5 and the current element is 9. So we are going to ask 5, can you be part of me? Can you bond with me or not? So how can 5 bond with 9? If 9 mod 5 is equal to 0, it will bond, right? But it is not, right? It is wrong. So we can say 5 cannot bond with 9. So in this case, when we are at this particular index, so the maximum DP, which includes 9 as the last element, is going to be 1, right? That is if your input is 5, 9 and if your subset is ending at 9, so this is going to be 9 and no other element, right? So the length is 1, and again for this previous is going to be -1. Now let us talk about 18. 18 is going to ask the same question from its previous elements, that can you bond with me or not? 5 will say I cannot bond with you because 18 mod 5 is not 0, right? But 9 will say I can bond with you. That is 9 can create a subset with Mr. 18, right? So in this case 18 got the answer from 5 that it cannot bond, from 9 it can bond. So it will take this yes and it will ask what is your DP length. So it is saying, hey, my DP length is 1, and if I include you, Mr. 18, then the DP length is going to be 2 because I got one more element, right? So when we have processed 5, 9, 18, we have got three subsets, 5, 9, and we have got another subset which is 9, 18. Why? Because with 18, 9 is saying that I can bond with you. So in this case, 18 got another element which is 9. So if 18 is including 9 in its subset, so till 9, the maximum length is 1. It got one more element, 18. So the maximum length is going to be 1 plus 1, which is 2, right? So if we have an input 5, 9, 18, then we can create a subset which is ending at 18 and the length will be 2, and that will be 9, 18. Now we know that 18 will be the last element, but what is the element before 18? We need to keep track of it, and that is why we are using this previous as well, okay? So at 18, the previous is not going to be -1, it is going to be 1. 1 means before 18, that is I bonded with index number 1, which is 9. Okay, so we are storing the index as well to backtrack to get our answers, because in the output we need to return all the elements. Okay, so before 18 we have 9, so the index of 9 is going to be the previous value of 18. We are going to make use of this as an index. So I hope this clears the fact that why are we using this DP and why are we using this previous. Now we can perform the same operation with all the elements, and let me do it. This will make things very clear. So if we are at 54, this is going to ask all its 3 elements which are before it that can you bond with me or not. Now 5 cannot bond, right? Because 5 cannot divide 54. But 9 and 18 both can bond, because 9 and 18 both can divide 54. So if both are saying that I can bond with you, we are going to take the one which has more DP length, such that our subset is having bigger length, the best maximum length we can get. So we are going to take 18 as the previous element of 54. So in this case, what we got is 54 will get an answer from 18 that I can bond with you and your DP length is 2, and I am giving you one more element which is 54. So the DP length is going to be 2 plus 1, which is 3. So now the DP length is 3, and what's the previous element of 54? This is 18, which is at index number 2. So the previous value of 54 is going to be 2. So that is what we are doing for each of the element. So let me show you for 90 as well. For 90, 9 is going to say yes, 5 is going to say yes, 18 is going to say yes, but 54 will say no, I cannot bond with you. Out of all these 3 yes, we have this as the highest length, right? 2. 2 is the highest length. So we can say 18 can bond with 90. So we are going to say 2 plus 1 is 3, right? Till 18 we have 2 elements. It got one more element which is 90. So the length is 3. And the previous element of 90 is going to be at index number 2, which is nothing but 18. Okay. Now if your input is just this much, that is, this is your array as an input, then what can be your output? Till now, how can you generate the output? And the process to generate the output is, we need to find the DP table first. So this is our DP table, and we need to ask this DP table that what is the maximum length you have got till now. So it will say, okay, I have got length 3 and length 3 2 times. That means I have 2 subsets with length 3 such that all the pairs are valid. So which one do you need to output? You can output any of it. So let us take this one. So if you take this as your output, so in this case 90 is going to be your last element. And what is the element before 90? You are going to ask the previous table. So it is saying that before 90, the index number 2 is going to be there. So we go to the index number 2 and we got the element as 18. So 18 will be included in our answer, and we will ask 18 that what is before you. So it is going to say index number 1. At index number 1, we have 9. So we can say, okay, 9 is also going to be the part of our answer. And what is before 9? This -1. And this -1 is representing that we don't have any more element before. So now we can stop. And 9, 18, 90 is our answer. And that is why we have initialized previous as -1. So now you are getting the thought process, right? Now you are understanding the thought process behind it. Now what if we are not choosing this one, but instead of that, we are choosing this as our output? So in this case, 54 will be the last element, right? So we can say 54, and before 54 we have 2, right? Index number 2. So we can go to index number 2, 18, and before 18 we have index number 1, which is this one. So it is 9, and before 9 the index number is -1. So we can stop here, and we got 2 and 1 index, which is 18 and 9. So before 54 we can say it is 18 and 9. So this is also a valid answer, and 9, 18, 90 is also a valid answer. You can return any of it. Now I think you understood the approach, right? You can just process for each of the input and then get the DP and find which has the maximum value, right? So for this complete input, 6 is the maximum value and the element is 720. So we can say 720 is our last element, and before 720 we have index number 7. So index number 7 is 360. Before 360 we have index number 6, which is 180. Before 180 we have index number 4, which is 90. Before 90 we have index number 2, which is 18, and before 18 we have index number 1, which is 9. So 9, 18, 90, 180, 360 and 720, and that is our output for this particular problem. So we just need to compute the DP table, the previous table, and then we are going to backtrack to get our answer. So I think this is the complete explanation of this particular problem. Now let me go back to the code editor and try to code it using Python. So first of all, we need to sort our input, right? So nums.sort, this will sort our input. Then we are going to take the length of our numbers. So n is equal to length of nums. Now we can assign two tables, dp and prev. dp will be equal to an array which is having 1 as all of its elements, so 1 into n, and previous will be an array with -1 as all of its element multiplied by n. Now we can loop into our element for I in range n. Okay, this loop is going to track each of our element, and then we can run a loop which is previous than our current element. So for j in range of I, so till I we are going to run another loop, and now we are going to check what are the elements before our current element I which can pair with I. So for that we can say if nums of I mod nums of j is equal to 0, then we know that this can pair, right? So at this point we can update our DP table, but there is one more condition which needs to be true, and that is if dp of j plus 1 is more than dp of I. This means that I will only pair with you if pairing with you is going to create better value, bigger dp value, right? So this is our current dp value and this is the dp value after pairing, right? So if this is going to be more, then in that case we are going to create our pair, right? So we can say dp of I in this case is going to be dp of j plus 1, and we are also going to update our previous of I, which is going to be j. Now you can also write this if condition directly here. You can cut it out and write an and condition, and you can say it like this, right? So this is also correct. So after processing this for loop, we will have the dp and previous table updated. Now we need to find out the maximum value which we have for our dp table. So for that we can say mx is equal to max of dp, right? But no, we actually need to find out the index at which we have the maximum value, right? So we can say mx idx is equal to, we are going to enumerate our dp to get the indexes as well, and the key to check for the maximum is going to be the actual value in our dp table. So lambda x, and we are going to say x of 1. So now using this we are going to get that element which has the maximum value in the dp, and the value we will get is the enumeration, right? So index as well as the value, and we just need the index, so we can say 0 of this, right? So this is going to give me the index of that element in the dp which has the maximum value. Now we know the index from where we need to start storing our result, so we can say result is going to be an empty array for now, and then we are going to run a while loop. While the value of mx idx is not equal to -1, that is we are not at the starting element, this will be result equal to, then we can say result dot append nums of mx idx, okay? And then we are going to update the value of mx idx. This will be equal to previous of mx idx, okay? So this while loop will update our result, and then we can directly return our return result. And before submitting this code, I should remove this if condition from here, right? So I can remove this if, this is a syntax error. So remove this and submit your code, and this should be a complete solution for this particular problem. Yes, it is a complete solution for this problem, and we can see that it is a pretty efficient solution as well. So I think that is it for this video, guys. So let me show you the complete solution. So this is the complete solution for this particular problem, and I think that is it for this video, guys. I hope this video clears you the question and the approach to solve this particular question, and if it did, then make sure that you hit that like button, and if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well, and I will see you guys in the next video. Thank you for watching this video, guys.